This article reading is from Techpowerup. It is on the Nvidia GeForce RTX 5090 Founders Edition review, the new flagship. Nvidia GeForce RTX 5090 Blackwell heralds a new chapter in 3D graphics, and we have with us a sleek new RTX 5090 Founders Edition graphics card. Gaming graphics have had several major milestones over the past 20 years, beginning with raster, 3D, pixel, and vertex shaders, and real-time ray tracing. Now, Nvidia plans to introduce the next major milestone, neural rendering. By now you're likely aware of generative AI. And its ability to conjure up richly detailed images and video. Nvidia and its allied researchers in 3D graphics have discovered a way to give generative AI a more active role in real-time graphics. With the introduction of neural shaders, the new Blackwell graphics architecture, besides bringing in generational improvements to performance and efficiency, also introduces DLSS 4, and with it, an exclusive new technology called multi-frame generation. The company claims to have figured out a way to get AI to not only create every other frame, but up to 4 frames following a conveniently rendered frame. Conventionally rendered. Not conveniently. This is a bold claim, but if Nvidia pulls it off, the RTX 50 series will really turn the page on what's possible with current technology. I need to set my status to do not disturb because I almost forgot, just so I don't get surprises or something. This is a bold claim, but if Nvidia pulls it off, the RTX 50 series will really turn the page on what's possible with current technology, and maybe even tempt game developers to give us our next crisis. That is an interesting statement, because thinking about it, Crysis had absurd requirements for like the ultra setting, but it was the type of thing that hardware like 4 years later could run it then at ultra. Meanwhile, it's like people now, it's like, oh, my 3-year-old top-end graphics card or 4-year-old top-end graphics card can't run this game at ultra, which it's like, yeah, I don't know. The new GeForce Blackwell graphics architecture sees advancements to all 6 key components in the GPU, the CUDA core, or the GPU's main unified shader engine, not just introduces generational IPC increases, but also redesigned to accelerate neural shaders. The 4th generation ray tracing core, besides continuing to lower the performance costs of ray tracing compared to the previous generation, comes with optimization for mega geometry, ray traced objects with much more complex geometry, more services for rays to interact with. The 5th generation tensor cores lay groundwork for not just neural rendering, but also introduce support for new data formats, including FP4. Nvidia has given all the components involved in AI acceleration a dedicated management engine called AMP. Next up, Blackwell also updates the media acceleration engines and gives its display I/O a much needed update, with support for DisplayPort 2.1 and UHBR20. Lastly, Blackwell is the first GPU to use PCI Express Gen 5 and GDDR7 memory standards. These are significant increases in memory bandwidth across the board. What's interesting though is that while GeForce Blackwell innovates in almost every direction, the entire line of GPUs is built on the exact same foundry node as the RTX 40 series Ada generation, a specialized variant of the 5nm EUV node at TSMC that the foundry co-engineered with Nvidia called TSMC4N. Any generational gains in performance per watt are purely from the architecture and new power management technologies introduced in Blackwell, not from the node. GeForce RTX 5090 is the company's flagship graphics card this generation and is based on the gargantuan 5nm GB202 monolithic silicone. The SKU enables 170 out of 192 streaming processors SM present on the chip, achieving 21,760 CUDA cores, 170 ray trace cores, 680 tensor cores, 680 TMUs, and 176 ROPS. The memory subsystem sees a major generational upgrade. The card comes with 32GB of GDDR7 memory running at 28GB per second, gigabits per second. G and then lowercase b, PS. Nvidia has widened the memory bus to 512-bit, giving the RTX 5090 an enormous 1.792 terabytes per second of memory bandwidth, the kind you'd expect from high bandwidth memory setups. On AI GPUs, these massive increases in memory size and bandwidth are crucial for the GPU to pull off high geometry ray tracing and neural rendering. Nvidia didn't limit its engineering just to the GB202 silicone, and its various software technologies such as DLSS4 and Reflex 2, but also the hard product itself. The Founders Edition card is a remarkable piece of engineering. It's just as long and as tall as the 4090 Founders Edition, but just 2/3 its thickness, 2 slot versus 3 slot. This is made possible by the new double flow through cooling solution that compacts and pushes the PCB out of the way to create 2 nearly unrestricted channels of airflow for the card's 2 fans. The Nvidia GeForce RTX 5090 Founders Edition comes with close to reference clock speeds of 2407 MHz boost, GPU boost, and 28 gigabits per second GDDR7 effective memory. With these settings, the total graphics power TGP of the de facto power limit of the card shoots all the way up to 575 watts, nearing the design limits of the 600 watt capable 12 volt 2x6 power connector. Nvidia is pricing the GeForce RTX 5090 Founders Edition at the SKU's baseline price of USD $1,999. This is a steep increase in price over the RTX 4090, which started at $1,600 or $1,599 US. There is then a chart of various graphics card models and their specifications, along with their pricing as well. I'm not going to read all of them just because it's the type of thing that's like, it's not directly the 5090, but the listed cards are the RTX 3080, 4070, RX 7800 XT, RX 6900 XT, RX 6950 XT, RTX 3090, RTX 4070, RX 7900 GRE, the RTX 4070 Ti, the 4070 Ti Super, the RX 7900 XT, the RTX 3090 Ti, RTX 4080, RTX 4080 Super, RX 7900 XTX, RTX 4090, and then the RTX 5090. I don't know why it's listed, the price of the 4090 is listed as $2,400. I wonder if that was like crypto pricing or something. I'm just gonna grab something to drink really quick. Excuse me. The GeForce Blackwell graphics architecture heralds Nvidia's 4th generation of RTX, the late 2010s re-innovation of the modern GPU that sees a fusion of real-time ray-traced objects with conventional raster 3D graphics. With Blackwell, Nvidia is helping add another dimension, neural rendering, the ability for the GPU to leverage generative AI to create portions of a frame. This is different from DLSS, where an AI model is used to reconstruct the details in an upscaled frame based on its training data, temporal frames, and motion vectors. At the heart of the GeForce RTX 5090, we are reviewing today the Mammoth 5nm GB202 silicone. This is one of the largest monolithic dies ever designed by Nvidia, measuring 750mm squared compared to the 608mm squared of the Ada 102 die. AD102, not Ada. The process is unchanged between the two generations. It's still an Nvidia-specific variant of TSMC's 5nm EUV dubbed TSMC-4M. The GB202 rocks 92.2 billion transistors, a difference of 20% or a 20% increase over AD102. The GB202 silicone is laid out essentially the same component hierarchy as the past generations of Nvidia GPUs, but with a few notable changes. The GPU features a PCI Express 5.016x, making it the first gaming GPU to do so. PCIe Gen 5 has been around since Intel's 12th generation core Alder Lake and AMD's Ryzen 7000 series Zen 4. So there is a sizable install base of systems that can take advantage of it. The GPU is of course compatible with older generations of PCIe. Whether this affects performance in question we have to cover in a separate article. RTX 5090 PCIe scaling. The GB202 is also the first GPU to implement the new GDDR7 memory standard, which doubles speeds over GDDR6 while lowering the energy cost of bandwidth. Nvidia left no half measures with GB202 and gave the board a 512-bit GDDR7 memory interface. On the RTX 5090, this is configured with 32GB of 28GB per second GDDR7. Upcoming RTX 50 series SKUs could have narrow memory interfaces but with higher memory speeds, and some professional graphics cards based on GB202 could even use high-density memory chips. The GigaThread engine is the main graphics rendering workload allocation logic on the GB202, but there's a new addition, a dedicated serial processor for managing all AI acceleration resources on the GPU. Nvidia calls this AMP, AI Management Processor. Other components as the global level are the optical flow processor, a component involved in older versions of DLSS frame generation and for video encoding, and the vast media acceleration engine consisting of 4 encode accelerators and 4 NVDEC decode accelerators. The new 9th generation NVIDIA video encode accelerators come with a 422 AV1 and HVAC encoding support. The RTX 5090 has 3 out of the 4 NVINC and 2 out of the 4 NVDEC units enabled. The central region of GPU has the single largest common component, the 128MB level 2 cache. The RTX 5090 is configured with 96MB of it. I find it funny reading this, and my own card is kind of just probably crying, trying to render the. I don't know if I can disable it. Oh, I can. I can't be bothered to. I have the mirror on still in the avatar testing world, and that's probably not doing me any good favors. Each graphics processor cluster is a subdivision of the GPU of nearly all components needed for graphics rendering. On the GB202, the graphics processor core cluster consists of 16 streaming clusters, and a raster engine consisting of 16 ROPs. Each SM contains 128 CUDA cores. Unlike AIDA generation, which had 64 FP32 plus INT32 and 64 purely FP32 SIMD units, the new Blackwell generation SM features concurrent FP32 plus INT32 capability on all 128 SIMD units. These 128 CUDA cores are arranged in 4 slices, each with a resistor file, a level 0 instruction cache, a warp scheduler, 2 sets of load stores units, and a special function unit SFU handling some of the special math functions such as trigonometry, exponents, logarithms, reciprocals, and square root. The 4 slices share 128 kilobytes level 1 data cache and 4 TMUs. The most exotic components of Blackwell SM are the 4 5th generation tensor cores and a 4th generation retrace core. Perhaps the biggest change in the way that SM handles the work introduced with Blackwell is the concept of neural shaders, treating portions of the graphics rendering workload done by generative AI as shaders. Microsoft has laid out the groundwork for standardization of the neural shaders with its cooperative vectors API in the latest update to DirectX 12. The tensor cores are now accessible for workloads through neural shaders, and the shader extension recording SCR engine of the Blackwell SM is able to be more accurately reorder workloads for the CUDA cores and tensor core in an SM. The new 5th generation tensor core introduced support for FP4 data 1/8 precision for fast-moving atomic workload, providing 32 times the throughput of the very first tensor core introduced with the Volta architecture. That would be 2000 series Nvidia. So 3 generations behind now. Over the generations, AI models leverage lesser precision, data formats, and sparsity to improve performance. The AI management processor AMP is what enables simultaneous AI and graphics workloads at the highest levels of the GPU. So it could be simultaneously rendering real-time graphics for a game while running an LLM without either affecting the performance of one another. That's interesting. AMP is specialized hardware scheduler for all the AI acceleration resources on the silicon. This plays a crucial role for DLSS4 multi-frame generation to work. The 4th generation ray trace core is not just offers generational increase in the ray tracing and ray intersection performance, which lowers the performance cost of enabling path tracing and ray traced effects, but also a potential generational leap in performance when introduced with the introduction of mega geometry. This allows for ray trace objects with extremely high polygon counts, increasing their detail, poly count, and ray tracing present linear increases in performance costs at each triangle that has to interact with ray tracing. Not ray tracing. And there should be sufficient rays to intersect with each of them. This is achieved by adopting clusters of triangles in an object as first-class primitives and cluster-level acceleration structures. The new RT core introduces a component called a triangulate cluster intersection engine designed specifically for handling mega geometry. The integration of a triangle cluster compression format and a lossless decompression engine allows for a more efficient processing of complex geometry. The GB202 and the rest of the GeForce Blackwell GPU family is built on the exact same TSMC 4N foundry known as the previous generation Ada, so Nvidia directed efforts to finding innovative new ways to manage power and thermals. This is done through a re-architectured power management engine that relies on clock gating, power gating, and rail gating of the individual GPCs and other top-level components. It also works speed of which the GPU makes power-related decisions. I'm just trying to look at a graph that I couldn't read. The quickest way to drop power is by adjusting GPU clock speed with Blackwell. Nvidia introduced a mean for rapid clock adjustments at the SM level. Nvidia updated both the display engine and media engine of Blackwell over the previous generation ADA, which drew some flack for holding onto older display I/O standards such as DisplayPort 1.4, while AMD and Intel had moved on to DisplayPort 2.1. The good news is that Blackwell supports DisplayPort 2.1 with UHBR20, enabling 8K 60Hz with a single cable. The company also updated NVDC and NVENC, which now supports AV1, UHQ, double to H.264 decode requirements, MV-HVENC, and 422 formats. Neural rendering promises to be as transformative to modern graphics as programmable shaders itself. 3D graphics rendered evolved from fixed function over the way of the century to programmable shaders, HL/SL geometry shaders, compute shaders, and ray tracing. Over the past couple of decades, in 2025, Nvidia is writing the next chapter of this journey with Blackwell neural shaders. This allows for a host of neural-driven effects, including neural materials, neural volumes, and even neural radiance fields. Microsoft has introduced the new Cooperative Vectors API for DirectX in a recent update, making it possible to access tensor cores within a graphics API. Combined with the new shading language, Slang, this breakthrough enables developers to integrate neural technologies directly into their workflows, potentially replacing parts of traditional graphics pipeline. Slang splits large, complex functions into smaller pieces that are easier to handle, given that this is a DirectX standard API feature. There is nothing that stops AMD and Intel from integrating neural rendering cooperative vectors into their graphics drivers. RTX neural materials work to significantly reduce the memory footprint of materials in 3D scenes. Under the conventional rendering, the memory footprint of a material is bloated from a complex shader code. Neural materials convert the shader code and texture layers into a compressed neural representation. This results in up to a 7:1 compression ratio and enables small neural networks to generate stunning film-like materials in real time. For example, silk rendered with traditional shaders might lack the multicolored sheen like real life. Neural materials, however, capture intricate details like color variation, and reflections, bringing such surfaces to life with unparalleled realism and at a fraction of the memory cost. The new Neural Radiance cache, which dynamically trains a neural network during gameplay using the user's GPU, allows light transport to be cached partially, enabling near infinite light bounces in the scene. This results in a dynamic, realistic, indirect lighting and shadows with minimal performance impact. NRC particularly traces one or two rays before storing them in a radiance cache and enters an infinite amount of rays and bounces for a more accurate representation of indirect lighting in a game scene. DLSS 4 introduces a major leap in image quality and performance. It isn't just a version bump with the introduction of a new feature, namely multi-frame generation, but introduces updates to nearly all DLSS sub-features. DLSS is a very beginning relied on AI to reconstruct details in super resolution, and with DLSS 4, Nvidia is introducing a new transformer-based AI model to succeed the conventional neural networks previously used. For double the parameters, 4 times the compute performance, and significantly improved image quality, ray reconstruction introduced with DLSS 3.5 gets a significant image quality update with the new transistor-based model. To understand multi-frame generation, you need to understand how DLSS frame generation introduced with GeForce ADA works. I'm just going to grab another thing to drink really quick. gives the DLSS algorithm data to generate an entire frame using the neural network, using information from a previous rendered frame, effectively doubling the frame rate. In multi-frame generation, AI takes over the functions of optical flow to predict up to 3 frames following a conventionally rendered frame, effectively drawing 4 frames from the rendered effort of 1. Now, assuming this rendered frame is a product of super resolution, which the maximum performance setting generation 4x the pixels of a single rendered pixel, you're looking at the possibility where rendering effort of 1/4 the frame goes into drawing 4 frames, or 15 every 16 pixels being generated entirely by DLSS. When generating so many frames, frame pacing becomes a problem. Irregular frame intervals impact smoothness. DLSS 4 addresses these issues by using a dedicated hardware unit inside Blackwell, which takes care of flip metering, reducing frame display variability by 5 to 10x. The display engine of Nvidia Blackwell contains the hardware for flip metering. Nvidia Reflex 2. The original Nvidia Reflex brought about a significant improvement to the responsiveness of maxed out graphics and competitive online gameplay by compacting the rendering queue with the goal of reducing the whole system latency by up to 50%. Reflex is mandatory in DLSS 3 frame generation given the latency cost imposed by the technology. Multi-frame generation calls for an equally savvy piece of technology. So hence we have Reflex 2. Nvidia claims to have achieved up to a 75% reduction in latency with frame warp, which updates the camera viewpoint positions based on user inputs in real time, and then uses temporal information to reconstruct the frame to display. Nvidia's RTX 5090 comes with a refreshed Founders Edition design theme. It's instantly recognizable as a Founders Edition card, but there has been small aesthetic tweaks, like more smooth corners, etc. Also note that both sides of the back now have cutouts for air to flow through. Dimensions are 30 inches by 14. Sorry. That would be wild. Dimensions are 30 centimeters by 14 centimeters, and it weighs 1,814 grams. And then there's photos of it next to a RTX 4090, which is the same footprint, but the thickness is reduced. 2 slots required. Card's width is 40 millimeters. Display connectivity includes 3 standard DisplayPort 2.1b and 1 HDMI 2.1b. Standard for all RTX 50 series Blackwell cards is the new display engine that supports 3 DisplayPort 2.1b outlets, each capable of UHB R20 and 1 HDMI 2.1a. Why did the previous sentence says HDMI 2.1b but in that same 2.1a? What weird. Both interfaces support DSC display stream compression. With DSC enabled, a single DisplayPort on the card can drive 4K 12-bit HDR at 480 Hz or 8K 12-bit HDR at 165 Hz. The RTX 5090 features an updated media acceleration engine with support for 422 video formats, AV1 UHQ, and MV HVAC. There are 3 independent NVIDIA units and 2 NVDEC. There's then some photos of the 8-pin to the 16-pin adapter. It is a new model that feels much better thanks to oh, this typo is funny. Thanks to software cables rather than softer cables, and a better plug for its more massive, so it can withstand more abuse. It is considerably bigger than the previous generation, and it's longer, and the cables are like sleeved fabric instead of like braided stuff, not braided like a metal mesh like on the previous generation. And the connector's angled again, which that's how it was on 3000 series, but then 4000 went to being flat. So, yeah. The card uses a single 16-pin connector, which allows for a maximum power draw of 600 watts. Nvidia has improved the location of the adapter, and its recessed down comes out on an angle. Nvidia's Founders Edition features white lighting on the GeForce RTX logo and all around the air inlets on both sides. The lighting effect is static. It can't be adjusted in color or brightness. There's also no way to turn it off. That makes me wonder if I know, for example, like the RTX 3090 or the 3000 series has a white LED on the GeForce RTX logo, and it's only possible to turn it off from my experience with EVGA Precision X. So I wonder if Precision X would be able to turn it off here, or if it's just not a thing at all. Teardown. Nvidia Founders Edition cooler uses large vapor chamber baseplate. 5 double-length heat pipes move heat away quickly from the GPU surface to the heatsink area. The rest of the article ties into teardown stuff, but it's heavily image based. Followed by there's a bunch of stuff about the circuit board, which again is heavily image based, and then the rest of this ties to their benchmarks. I may look at reading this again some other time, but I just realized it is getting late for me, so I am gonna have to cut it here. But I don't know. I think the RTX 5000 series is interesting for what it is, but as a Canadian, I'm not excited about the pricing, especially for the high-end stuff. Given that the Founders Edition card for 5090 is $2,000 US, the least expensive AIB model is $2,900 Canadian. Most expensive model is $4,500 Canadian. I don't care what sort of special stuff there is with it, but I don't think a near 2x price increase is justified on a card like this, because there's no way it's going to bring you 2x the performance. Maybe 2x the noise reduction, but Same also with the 5000 series, the 5080, $1,000 US. Okay, Canadian. The most expensive model is $1,850 Canadian, roughly speaking. But yeah, I don't know. It's just a lot of money for a single component computer, in my opinion.